Hey everyone, welcome to iCode. Today we are going to take a look at 1020 number of enclaves, and this is today's Leetcode challenge, daily Leetcode challenge. So this is medium problem. It's been asked in Amazon a couple of times last 6 months to 1 year, and then in Google a couple of years ago. So let's take a look at this problem. This is a standard matrix DFS VFS grid search problem. Let's give it a read, and then I'll explain the intuition, and then we'll code it up. So you given a matrix m by n binary matrix grid where 0 represents the C cell and 1 represents the land cell. Move consists of walking from one land cell to another adjacent for directionally land cell or walking off the boundary of the grid, right? Return the number of the land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. So we don't care how many number of moves we have to take. We can move four directionally: up, down, side, left, and right. And then they are asking to return how many cells we have on the land from which we cannot walk off to the grid, or we cannot go to the boundary of the grid. So this is like, for example, in this example, see, we have two groups. This is one group of the land and this is another group of the land, and you can walk off this grid, right? This one particular cell, but here there is no way that you can go because it's surrounded by all the water C cells, right? So we have to return number 3 because there are 3 cells, which land cells, from which we cannot go to the border. Here we have only one group with how many cells are there? Four cells, but since these two are on the border, we can walk off the grid or we can go on the border. So pretty easy, I would say. Intuition wise, we will do the DFS, right? We'll do DFS, and we definitely going to find the groups and count the number of the cells in that group. So I'll start iterating over it. Whenever I come across the cell which is not seen already and which value is 1, that's when we start our DFS. When I start my DFS here, I will iterate through everywhere to all of its neighbors and try to find whole group of the land. And at any point, if I come across the land cell which is on the border, so we can define one function which is like is border, that will return if I pass this particular cell to that border, it will return if this cell is on the border or not. So if at any point if that returns true, then we flag one variable which would set it to the true. And when I have iterated through whole group, when my DFS for that one group ends, and then I get out of that loop, and then we check if our is border flag is true, then that means we can go to the border, right? From that group. But let's see, here I'm at here and I have traveled everything, right? And then since these two are at the border will be true. So in that case, I don't add these four to the answer, right? But in this case, suppose I have traveled all these three, but none of this is on the border, so border will still be false, and in that case I add these three to the answer, and that's it. So we will have to keep one global variable which will keep track of the answer, and then one variable which we would reset for every group. So for this group it would be 1, for this group it would be 3. So that is pretty much intuition. So what are we going to need is DFS, one is border, after that is border. For the border purposes, we'll keep a flag which would be true or false depending on if we have seen the border land cell for that group. When I say for that group, it's gonna be this group, like this island, I'm gonna say. And then we will keep one variable is current count, which would be current count would keep track of this land cells in that particular island or the group, so it would be 3, right? Count of cells, count of land cells actually. So in that case, when we exit from this, we know how many to add, right? And anyways, even if at any point we suppose I found some cell here which is true, right? Which will make the border as true now, and then it doesn't make sense. You might think that it doesn't make sense to keep continue, but it does, because we do not want to iterate. We do not want to do DFS on what we have seen, so we have to make sure that we see everything complete DFS, right? Okay, so let's get started on coding this. So when we're doing the matrix DFS, first we start with row and column. Row equal to length of grid, column equal to length of grid of 0. So that's basic, right? We'll need one variable answer equal to 0. This is what we will return, and then we need to go 4 directionally, right? So for that we're gonna need one variable. No, it's kind of a array direction, which will, this is pretty standard for DFS grid problems. So let's define those directions, and then 0 minus 1, right? And now we start iterating, right? Before we iterate, we need scene as set, right? And then here now we start for I in, we're gonna iterate over the row, for j in range of column, right? Now we check if I comma j not in scene, because we don't want to start DFS on what we have already seen, right? And we don't want to start DFS on the C cell, right? Definitely we want it on only land cell. So we're gonna say grid of ij equals 1. In that case only we will do is DFS of I comma j. But see, I need to keep track of how many cells are going to be in that particular group, right? So and then if that group has any cell which is on the border, so for that purposes we're going to declare 2 variables which I mentioned here, right? Border and current count. So current count is going to be 0 first, so it's going to be 1 because this is the one cell as well, right? So current count is going to be 1, and then border will be false for now. And then we have DFS, and then in the end, once DFS ends, we check if border equals false. So we haven't seen, if border equals false, that means we haven't seen any cell in that group which is on the border, so that it's going to remain false. And then if it is false, then yeah, from that particular group, whatever is the count of the cells, from all those cells we won't be able to reach to the border. So that's when I do answer plus equals, or let's do equals answer plus current CNT. And when I start the next DFS, we'll reset the current CNT again, right, to 1. So now let's start defining the DFS. So def DFS will get I comma j as the variables here, and then let's see, we have to declare the, since we are not passing these current and border, let's make them non-local here. current cnt, right? Yeah. Now first thing we do, dfs, we add it to the scene, right? Scene dot add that I have seen this particular cell I comma j, right? Now we check if this particular cell is on a border or not. If it is, then like we have to update our border variable. So if, let's call it is border, this one will get, it's is border, yeah, it's gonna take I and j. And like let's see, this is what we're gonna check. And so suppose here you see we have two well, yeah, we have two on border, so we want to set it only if it is not true initially, right? If we haven't seen, otherwise we don't have to go and set it. So we're just going to check quickly that and border equals false. So if it is false, so we haven't seen any cell which is on the border first, and that's only when we will make it true, right? So that's done, and we will have to define the border, but let's is border here I comma j, and we'll come back to this in a while, right? So once that is done, what we're gonna do is, suppose we are at this, we have to check all the four sides, right? So let's iterate over that. So for direction of I, d of j in, so we have this defined here, right? So we can use that, and then in dr of n. Now this will give us next I and j, right? Which is going to be di plus I comma dj plus j, right? Now before we go and call dfs on this, we have to check few things, right? If these things are in border, if this one is in border, if this is a land sale, or if this is not in scene already. If none of those, if any of those are not true, then we don't want to iterate, right, over this cell. We don't want to call dfs on that. So let's check that. So if next I, this has to be greater than or equal to 0, and next I has to be less than row, right? And next j has to be greater than or equal to 0, and next j has to be less than column, right? Makes sense. So we don't go out of bounds, so we have to check that. Now we have to check if it is a land cell, then only we call dfs. So let's check grid of next I and next j equals 1, right? And that is not in scene. Next of I comma next of j, this thing is not in scene, otherwise we'll be keep iterating forever. Not in scene. Once that is done, we go ahead and call dfs. So dfs of next I comma next j, but see, we have to increment, right? We have to increment our current count because current count increased now, right? So we're gonna check current cnt plus equals 1. So there is one more cell added in that group, right? And then we call dfs on that, right? So that is dfs pretty much. And then let's define is border, right? Is border is pretty simple function. It's just gonna check if I and if any of these I or j, any of these is on or border. So if I is 0 or equal to row minus 1, or j is 0 or column minus 1. So let's check if I equals 0 or I equals row minus 1, row minus 1 because this is 0 index, right? Row is going to be, value of row will be 1 2 3 4 4, but we're starting from 0, so it will never exceed to 3. So we have to check if it is 0 or 3, or j equals 0, or j equals column minus 1. If that is true, then that cell is on border, so we return true, else we just return false, right? So yeah, um, that's it pretty much. And then yeah, of course we have to return answer, right? Let's run it. Yep, 3300 expected. Let's submit it. Hopefully, yeah, it's accepted. Not a great, but it works. Time complexity wise, it's often, because we're gonna iterate through the whole array, right? Sorry, whole matrix, so it's often. For memory complexity, scene will have everything which we have seen, right? So if I have sometime the, if I have all land, then scene would go to O of nm, but we might not have all land, right? Grid of ij, yeah, it doesn't say anything about this, but then yeah, it would be time space would be O of 1 so far, or if we have all land here, then it could go to O of n by m, because we will, at that point we will store all the values, right, in scene. So that time it could go to the O of nm, but for now we just have variables, direction array, which is not going to change. Scene is the set which would have all the values which are land, and can be of 1 and O of n, worst case scenario, right, n by m. But yeah, so this is it. Let me know if you like the content, down into the comments. Like and subscribe, and if you want me to do any other video on any other problem, let me know. Thank you.